Hi there, Mrs McTaggart here, and in this video we are going to look at the final part of the arcs and sectors chapter, the ones where you have to work backwards, the ones that everyone finds a wee bit trickier and involve a bit of change of subject, and you can either be asked to find the angle at the centre or maybe the radius or diameter of the sector. So let's have a wee look at these then. So, straight into the question. Number 1, we are given this sector here, we are told the diameter is 15, we want to know and we're also told the arc length, we have to find the angle at the centre. So a good place to start is you start with your arc formula. So the formula for arc was arc equals, it was angle over 360 times pi d. Okay, now I'm going to teach it using the change of subject method. So I'm going to change the subject first. I am after the angle in the centre, so I want to isolate the x. And then I'll plug in the numbers. So to isolate the x, what we're going to do is we're going to undo the divide with 360. So we're going to do arc times 360. And that would leave you with x times pi d. Okay. Now from there, we need to still get the x on its own. So we need to undo the times by pi d. So we need to divide by pi d. And I'm just going to cheat a little bit and I'm going to go back. And I'm going to just divide by pi d. Now you can divide by that collectively, like that, and just write pi d in the bottom. Now I have my formula to get the angle, so I can plug in my numbers. So my angle is, my arc is 10.6 times 360 all over pi times my diameter is 15. Now, if you've got the lovely fraction button that when you press it, it comes up like that on your Casio calculator, you can just put the fraction button and type that in as exactly as it is. If you don't have that fraction button and you've got maybe an older version calculator or a different make, I would urge you to maybe just do it like this and do a bracket around the top and the bottom lines so that your calculator is working out the top and bottom lines separately. And if you type this in, okay, you get an answer of 80.978. I'm quite happy for angles to go to the nearest degree. So it's 80.978. That's 81 degrees in my book. So the missing angle in the centre is 81. Now, if you're struggling with change of subject, I might show you a different way. A wee kind of foolproof way to do this one. Let's plug straight into the formula instead. So let's say that we have our angle, let's change my pen colour, we'll do it in green. So I'll have angle over 360 times pi times 15 equals 10.6. Oh, just fitting in there. So another way of doing it is you could work out what pi times 15 and then divided by 360 all gives you. And it gives you this ugly big decimal here of 0.130 ... That's my sign for sure. I'm using the exact answer in my calculator, but I'm not rounding. You get this equals 10.6. And then you need to undo the times by the decimal, so you divide by that decimal. So you do 10.6 divided by 0.130 ... and use your answer button and just do 10.6 divided by your answer button and you will get the same answer of 81. So that is another way of doing it if you're not so great on the change of subject, because your first mark is for substitution, your second mark is for getting to the rearrangement bit, and then your final mark is for the answer. So you might prefer that way, but from my experience recently, I've had classes that are really good with change of subject, so I'll do it the blue method. Right, let's look at another one. This time we are told the area of the sector and asked to find the angle at the centre. So once again, I'm going to start with my area formula. So area equals angle over 360. Now the area one was pi r squared at the end. So on this, I want to isolate the x. So this is what I'm trying to get on its own. So let's undo everything. I'm going to do area. The opposite times by divide by 360, is to times by 360. And that'll give me x. I still need to move this times pi r squared. So that's going to become a divide by pi r squared. So then I do my substitution. So I have 42.84 times 360 all over pi times a radius of 4 squared. And if you type that in, remember what I said again, you can use your fraction button and just type it in as it is, or brackets around the top and bottom lines. And if you type it in, you will get an answer of 306.8, so I'm going to say 307 degrees, which certainly matches my picture. It is a big angle, close to 300 there. Okay, and remember, one other way, let's go try even simpler way if you're really struggling with these. Let's start with your substitution, and you would write down right angle over 360 times pi times 4 squared equals, and I'm just going to put the equals to this side, 42.84. And you could just say, right, x equals, start with your area, and then think of all these opposites. There's a divide by 360, that becomes a times 360. Then you've got a times pi, that becomes a divide by pi. Then you've got a times 4 squared, that becomes a divide by 4 squared. And if you type that all in one long go, you'll still come out with an angle of 307. So after this example, I've shown you 3 different ways of solving this question. Change the subject, sub in, work out what you can, then rearrange. And then this one, which is sub in and do complete opposites left to right. Here is my final example. It's not always the angle at the centre you're asked to find. Sometimes you're asked to find maybe the radius or the diameter. In this case, I'm talking about a pendulum. Pendulum is swinging through an angle of 65. They've told you that the arc length is 28.4, and they don't want the angle at the centre. They want your radius. Now, your formula for arc is angle over 360 times pi d. So I want the radius, but technically I'm just going to go get the diameter first. And once I've got the diameter, I'll get the radius. Now, to change the subject on this one, I will do arc. Opposite divide by 360 is times 360. And that will leave me with an x times a pi times the d. So I need to divide by x times pi. So I'm taking that over to that side, and that will leave me with my diameter. Now if I go do my substitution, I have diameter equals 28.4 times 360 all over pi times, oh, I've put my pi and my x the wrong way around there. Doesn't really matter, but just to keep my working right, it would be 65 for my angle times pi. And go to calculator. That gives us an answer of 50.0067. So let's go with 50.07. So if that's your diameter, your radius is half of that answer, which gives us 25.0. It's 35. I've used my exact answer on the calculator, and it gives me 0.3. It really doesn't matter. If I want to be exact though, so I would probably, if I go back here and say, well, that was 50.6 something to show I'm not using my unrounded answer. To show I am using my unrounded answer, my radius would then be 25.03. They're really not going to penalise you with the rounding there on that one. So it's really common for pupils to round here and even say the diameter is 50, your radius is then 25, and it's a tiny bit of inaccuracy. But there we go. I hope that's helped. What I've got now is I have got these 6 examples, all calculator ones. So the first 4 are working to get an angle at the centre. Second 2 are to get your radius or diameter. But your answers are there, and hopefully you can screenshot that, or you can work to do them. It's up to you. I hope this has helped. Thanks for watching.